Hello, students. I'm back with part 4 of lesson 4.7. Today we're going to be talking about the inverse tangent or arctangent function. Again, your key objectives are to understand the inverse tangent function, where it comes from, and how to evaluate it. Let's go ahead and get started. The tangent function, as we learned in earlier units, is the function that ends up having a lot of asymptotes. So our tangent function is that function. We use the acronym asymptote, low, zero, high asymptote. So these two vertical asymptotes here are going to show up in our arctangent function or inverse tangent. And really, it's this one unit that we're most concerned about, that one period, really close to the origin. So as we look at the key features in terms of the domain and range of our original tangent function, we'll see that the domain is stated as all real numbers except at x equals plus or minus pi over 2n. And n is an odd integer, so that would be 1 pi over 2, 3 pi over 2, 5 pi over 2. Notice that these are all the increments in which we end up having our vertical asymptotes. So all numbers work except for at our vertical asymptotes. You'll see that the range is all real, so everything is going to work for the range. Now, consistent with what we've seen, the range of our original does become the domain of our inverse. However, it's the range of our inverse that gets switched up. And the reason it gets switched is because without restricting it, we end up having too many possible answers, and it causes us a little bit of trouble. So as we take a look at our possible outputs here, you'll notice that we're not actually going to include negative pi over 2 and positive pi over 2 as possible answer choices. And the reason is because those were asymptotes in our original, and when we do that inverse, they become asymptotes in that arctangent or tangent inverse function. Now, the biggest difference between this and the sine inverse and cosine inverse is that I can actually evaluate this at any value. This is always going to work. Now, looking at the unit circle, so to speak, we want to make sure that we also are understanding that restriction. So our arctangent or inverse tangent is going to work at any value that goes from negative pi over 2 to positive pi over 2. The only exception is that it actually can never be negative pi over 2 or pi over 2, because at those points it is going to be undefined. Let's go on and do some examples together. Now, I often find that the tangent inverse causes students the most trouble, and that's because we have to do a little more work to figure out where this occurs. So let's just take a second and review that. If we want to find like tangent of pi over 6, for example, I have to take the sine coordinate at pi over 6, and I need to divide that by the cosine value at pi over 6. In this particular case, using my unit circle, which is pasted right below this, that means I would have to take 1/2 divided by root 3 over 2. Now, this is a complex fraction, and in order to simplify this complex fraction, we have to multiply by the reciprocal of the denominator. In doing so, you'll see that the denominator ends up multiplying to 1. And on the top, we end up with 2 over 2 root 3, which is 1 over root 3. Now, we won't typically see our problems written in this format. We will always rationalize. So multiplying by the square root of 3 on the top and bottom, this gives us root 3 over 3. So if you want to, you could even jot that down. Hey, tangent of this value is root 3 over 3. You'll start to understand how those values show up. For example, at pi over 4, the tangent is going to equal 1. And the reason that happens is because root 2 over 2 divided by root 2 over 2 equals 1. And again, that's that tangent of pi over 4. So you'll see that we'll have to embed in that kind of processing as we go throughout this next part. So let's go ahead and take a look. The first one is tangent inverse. So right off the bat, we're going to exclude quadrants 2 and 3. And we're going to look for which quotient of sine divided by cosine produces a positive 1 out. And in this case, we get pi over 4. All right, moving on to the next one. Cotangent inverse of 0. Now, with secant and cosecant, we flipped the fraction. In flipping this one, it will cause it to be undefined. So instead of flipping it, we're going to ask a different question. We're going to say, when is cosine divided by the sine coordinate equal to 0? So again, we're asking the question, when does this happen? And in looking at our different coordinates, we'll just start with the center one. This one would be 1 divided by 0, so that's not going to work. Let's go up here because just naturally we would go to that top point. And so at that top point, if I took the cosine value of 0 divided by 1, I get 0 out. So in this case, pi over 2 would be the answer. Now, you might say, well, Ms. Vernon, you said we couldn't have that. I said you couldn't have pi over 2 with tangent, but cotangent has that slightly shiftedness, and so this one actually is pi over 2. All right, and remember, we didn't rewrite it in terms of tangent inverse, we wrote it in terms of cotangent inverse. All right, let's look at letter C. So letter C is saying arctangent. Remember, arctangent is really just a fancy way of me saying tangent inverse. And it is negative, so we know we're looking in quadrant 4. So we're somewhere in here. Remember, those values that we get for answers are going to be negative values. And as we look, we know already that this coordinate right here is going to be, when I do the tangent of it, negative root 3 over 3. We found that from before in our processing. So let's test this coordinate here. So in testing that, I would say is negative root 3 over 2 divided by 1/2. What does that equal? So multiplying by the reciprocal gives me negative root 3, which is what we were looking for. Now, again, we don't want to write 5 pi over 3 because that's not within our restricted range or output. So instead of writing 5 pi over 3, I'm going to write our answer as negative pi over 3 because negative pi over 3 falls within the allowed output or range of our restricted inverse tangent function. All right, last but not least, we are going to look at a composition of functions. So again, with composition of functions, don't get caught up too much. Just start with the innermost. So we have tangent inverse of -1. So where in quadrants 1 and 4 will I get a -1 out? And you should be saying, hey, right down here. Now again, we're not going to say that this is 7 pi over 4. Instead, we're going to state that this is going to be negative pi over 4. Now, again, just wanting to stay true to what arctangent restricts us to get for an answer. Next, we want to take what is the cosine value at that particular radian measurement, and in finding that, you will get positive root 2 over 2. To finish today's lesson, I'm just going to take a moment and review a few things with you that are sometimes confusing for students. The first part that I want to review with you is this notational part. So oftentimes students want to say that sine to the -1 is 1 over sine x. I want to be very clear on this. This is not going to be a true statement. False statement. Do not make this. Sine inverse is basically asking you to find the radian measurement that would give you that value for that coordinate. The second thing that students sometimes forget is that trig functions, inverse trig functions, have two ways of indicating that they are inverses. The most common is using this -1 notation. But as you saw me start to incorporate in more and more throughout the lessons, we also can use this idea of arc, which just means inverse, for these trig functions. And the third and final component that I want to review with you is this notation of when we do the inverse. Oftentimes we want to say these inverses are going to negate each other, but that's not always true. So for example, some of you may be tempted to say the answer to this particular problem would be 2 pi over 3. That's not correct, and here's why. Sine of 2 pi over 3 puts us up here. And the sine value in that particular quadrant is going to be, let's see, we got -1/2 comma √3 over 2. So the sine value there is √3 over 2. But once I apply that inverse, what I'm going to find is that it does not allow me to stay in that quadrant. Now that I'm applying the inverse sign, I need to flip this point into its positive quadrant. And that's why we end up getting pi over 3 out. It's very important that you always do all your evaluating. Sometimes it will end up being the same, and that's usually when it falls in quadrant 1 because those inverses are going to end up keeping us in the same spot. But let's just quickly evaluate this. So in this particular case, we're at this middle coordinate, √2 over 2, comma √2 over 2. And I go ahead to find my cosine inverse of that √2 over 2. And in doing so, it puts me right back at the same point because cosine inverse is restricted to quadrants 1 and 2, and it's positive in quadrant 1, which is why we end up getting the same thing out. It will happen sometimes, but it won't happen always. So definitely be sure to be cautious around these types of problems. I hope this tutorial is helpful, and I hope that you are understanding the content. Let me know if you have any questions.